didn't put them into the gradebook yet because I didn't have some of them from some of you, and we might have to make a little bit of a curve out of it. So we can just go through them real quick. Anyway, so number one, you're supposed to come up with your own function. Wasn't that fun? So you just draw something, and you got a point for a absolute max, an absolute minimum. Okay, a local max and a local minimum. I'm a highly paid professional. Okay, so that's 4 points for that. All right, then the next one, you sort of had to graph the thing so that it matched certain requirements. So we wanted an absolute minimum at 2. That could be really anywhere you wanted it, but most people put it below the x-axis. Absolute maximum at 5. 1, 2, 3, 4, 5. So some sort of a maximum up here. What? Right. A local maximum at 3. So there's some sort of a high point here, and then local minima, that's the plural of minimums, at 2 and 4. We have it. Okay, so there's really only one little trick here, and that is that the function is only from -4 to 5. 1, 2, 3, 4. So you go like this, and then you go like this, and then you go like this, and then we're supposed to stop. Jeffy went like this, which would imply that that's not actually the absolute maximum. So I don't remember. Pretty minor. You think so? Okay, so 4 points for that for labeling each one of those points. Okay? Stop me if you have any questions. All right, number 3 was kind of weird because it's only from 0 to 2. Again, the only trick here was, mathematically speaking, it says x is less than 2, but not equal to 2. So that is technically an open circle at that point. Okay? So the little part of the parabola is going to look like that. So the minimum value, obviously, is right here. The maximum value doesn't exist. There isn't one because of that open circle. Okay? So that was 3 points, 1 for the graph, 1 for the local minimum, and 1 for no local maximum. Maybe.
No, I did that right.
Okay. Pretty light. All right, next one. This one was the first one that was actually challenging. To define the critical numbers of this function. So what do you do first? Right, you're going to take the derivative using the product rule. That is correct. So that's the first function times the derivative of the second function. So we put 2 in front. Subtract 1 from the next one, makes it to the first. So who cares? So the times the derivative of the stuff inside and the derivative of that stuff is just 1, right? So that doesn't change it. So first times the second plus the second one times the derivative of the first. And there's still some of you in here that do that derivative backwards, which is mathematically fine, but it just makes it hard for me to get into that. But whatever, I can get through it. Okay, then the algebra gets really dicey from here. And this is where we struggled a little bit. And Jeff was asking me last week, that this chapter seems easier than the last chapter. And I said, the calculus is, the algebra starts to get a little bit complicated. Okay? It's one of those. And so this is certainly an example of that. So distribute the 2. Do we go through that slowly? How to distribute the 2? Oh, okay, got that. Understood. And then if you FOIL this out, you get x squared minus 8x plus 16. And then that is 12 times 4/5 x to the negative 1/5. Okay? So far so good? Alright, now I'm going to distribute the x to the 4/5. So that's going to give me 2x to the 9/5 minus 8x to the 4/5. Yes. Okay? Then if I distribute this, that gives me 4/5 x to the 9/5 again, because this is like 10/5 minus 1/5 would be to the 9 fifths minus 8x to the 4 fifths. If you remember, we're adding our exponents, so 1 plus negative 1/5 is 4 fifths. And then this is going to be plus, I think I want to start to go decimals here. 30, no, what is that? 64 over 5. X to the negative 1/5. How do you feel about that? Fantastic. Okay, so now we have some right terms that we can combine. And I'm going to go decimal here. So I've got x to the 9 fifths and x to the 9 fifths. Two of these and 4 fifths of those. So that's 2.8x to the 9 fifths. Feel good about that? Okay. Minus 8 of these, minus 8 of these is minus 16 x to the 4 fifths of those. So we're done with that, right? Okay, and then this 64 divided by 5 is really 12.8. Divided by 10 is 6.4, then double it, 12.8. Okay, 12.8x to the negative 1/5. Okay, so now we have this all simplified down. What do we need to do with it? Right, and we're setting it equal to 0, okay? So when you have all these crazy exponents, we talked about this before, what power of x should I factor out? The smallest. So we factor out an x to the negative 1/5, and then magical things begin to happen. Because this will be 2.8x what? Squared. Yay, that's the whole number. Minus, this will be 16x, because then that will be, 4 fifths again, and then plus 12.8 equals 0. And so now you have a simple, my wife and son are having a long conversation, but I can't get out of it. Now this obviously tells you that x can't equal, well, okay, we need to be a little careful with this. Remember, critical points are where the derivative equals 0 and where it's undefined, right? So x to the negative 1/5 is like 1 over x to the positive 1/5. So what would make this be undefined? 0. So that's one of your critical points. And then you go, quadratic formula in your calculator or whatever on this, and you get the other ones are 1.143 and 4. This is 87 also if you do that. Okay? So 4 points for this problem. One is the derivative correctly, and then 1 point for each critical point. Yes? Okay. Yeah, so you get 3 out of 4 points. Yeah, a lot of people miss the 1 point. That's okay. That's right. We'll keep working on that. Okay, number 5. Find the absolute maximum and absolute minimum values of that on the interval only from -2 to 3. So first step is graph it. No, definitely don't graph it. And I'll consider it because I know you're going to take the AP calculus test and you will have to do problems like this on the non-calculated section. So don't use your calculator as such so much. What? Take the derivative. I thought Hannah was going to share some words of wisdom with us. But she did. Okay, so then what do I do with that? Set it equal to 0, and so when I do that I can factor out 6. And so then this factors into x minus 2 times x minus 1. So what are my numbers that I care about? 0. Why do I care about 0? I don't really care about that. 2 and 1. So which, okay, yes, 2 and 1, and yes, -2. And I think I do that very well. Yep, thank you. I knew one of those would get thrown out. Sorry, I factored that incorrectly. So this would be +1, which, oh, it's not 6. So, okay, so it's 2, -1, -2, and 3. Okay? Alright, then you have to take all of those and plug them back into the original function to see which is the biggest and which is the smallest. And again, it seems like some of you got 3 out of 4 of these, but not all of them for some reason. I don't know why. But f of negative 2 comes out to be negative 3. F of negative 1 is 8. F of 2 is negative 19. And f of 3 is negative 8. So on this interval, this is your maximum and this is your minimum. Okay? Okay. The one that what? You have a question on problem number 2? You want me to go back? Okay. She said reduce the question. Okay. What is the question number 2? Oh, because it says at 3, not of 3. Okay? That's a very subtle distinction there. And then just while we're at it, this is something that you will appreciate, I'm sure, Anna. How many syllables does that word have? How many syllables?
Sorry, I was counting letters. One.
1. How many does it have now? 3. Oh, maybe. Yeah, 1 letter and it has 3 syllables. No? Nothing like that? I thought that's kind of a little Hannah moment that I was having there, but okay. Yeah. I understand. Okay. All right, number 6. Verify that that function satisfies the 3 hypotheses of Rolle's theorem, which I'm sure you all remember. What's the first hypothesis of Rolle's theorem, or what's the first condition? Right, it has to be continuous. And how do we know that it's continuous? Because it's a polynomial. Okay, what's the second condition of Rolle's theorem? Differentiable. And how do we know that it's differentiable? So you take the derivative and you get 3x squared minus 2x minus 6. And that's a polynomial, so you know it's differentiable everywhere. What's the third hypothesis? And this is the one that many of you forgot it. Right, we're going from 0 to 3. So we need to know that f of 0 equals f of 3. They need to be on the same y value. And f of 0 is 2, and f of 3 is also 2, so that checks out. So all 3 of these are good to go. Okay? Alright, then the next thing we need to do is take the derivative and set it equal to 0. Well, we already took the derivative, so let's just set that equal to 0. So you do a quadratic formula, this is the one that has an extra one. So if you set that equal to 0, you get x equals 1.786 or negative 1.20. But you don't want that one because it's not in the interval from 0 to 3, so we just below it. Okay? Alright, is everyone winning? No. Okay, next one, number 7. Use the graph to estimate the values of c that satisfy the inclusion of the mean value theorem. And I'm sure you remember that said that there's a point in there somewhere that has the same slope as the secant from here to here. So all I did is I took actually just the edge of the and I made that match those 2 points roughly. And then you go up here, and so that it looks like right about there's a point that has the same slope. And if I keep that parallel to those things, it's immediately my technology will be 20. There's another one. And then it's right there. And then there's this one. Okay? So I didn't really ding you on your estimating, but what you do want to stay away from is don't tell me 1 and 3 and whatever that is, because those are horizontal. So you need to be a little bit off of those. Okay, well, let's start. Alright, number 8. Verify that the function satisfies the hypotheses of the mean value theorem. So what were the hypotheses of the mean value theorem? Yeah, the mean value theorem only has two. First of all, it's continuous. Now that might have made you go, wait a minute, because this isn't continuous. Where is x over x plus 2 discontinuous? Right, at x equals -2. But why does that not cause us a problem in this case? Right, because we only care about on that interval. So that is okay. And then the other one is differentiable. So take the derivative and show that it is fine. So the derivative of this works out to be 2 over x plus 2 squared, which is 30. So it meets all of those conditions. Then it says find all numbers c that satisfy the conclusion of the mean value theorem. So now I have to look at x1 is what? No, x. 1. And x2 is 4. Okay? So then y1 is what I get if I plug that into there. So 1 over 3 is 1/3. And then y2 is what you get when you plug this into there. So that's 4 over 6, which is 2/3, right? So I'm doing what Hannah did with the other problem. I'm finding the slope of the graph from 1 to 4. Okay? So the joys of being a calculus teacher. y2 minus y1 is 1/3. x2 minus x1 is 3. How many people, any guesses, wrote that the answer to that was 1? A lot. Many of you. Okay, 1/3 divided by 3 is not 1. Okay, if it was, then you could just create like wealth out of nothing. You could take 1/3 of a pie and then divide it into 3 pieces, and magically you'd have an entire pie. You could feed the family. It'd be awesome. No, 1/3 divided by 3 is 1/9. Okay, yeah, that's okay. It happens. So that means that I need to take this derivative here and set it equal to 1/9. So 2 over x plus 2 squared has to equal 1 over 9. So I just cross multiplied and said x plus 2 squared has to equal 18. Square root both sides, so x plus 2 equals plus or minus, but I guess I don't need the minus because I only want on the interval from 1 to 4. What is that, 3 root 2? And then subtract 2 from both sides, so 3 root 2 minus 2, which you could also write as approximately 2.24. Okay? Norms. All right, last one, number 9. Show that that equation has exactly 1 real root. So first we're going to show that it has at least 1 real root. How do I do that? I don't even actually have to, not yet. No. Yeah, good. I'm going to plug in a negative number there that's going to give me a negative answer. And then I'm going to plug in a positive number that's going to give me a positive answer. And that tells me that if it gets from negative to positive and it's continuous, it has to pass through the x-axis at some point. So it has to have at least 1 real root. Then the way I have to prevent it from having more than that is I can't let it turn its direction and go through the x-axis again. So what would be true if it turns direction? Right, you would have a place where the derivative equals 0. So if I take the derivative of that, I get 2 plus 3x squared plus 20x to the 4th. And if I set that equal to 0, I get no solution. So that means that it has 1 real root and in fact exactly 1 real root. Okay? Okay, any questions about that? Alright, so, moral of the story, if you feel like you didn't do very well, I gave you the sheet with all of the stuff that we're going to do on there, and there were problems on there that sort of went with those ideas. And so a great way to study would be to, look at those things and maybe pick some of those problems and do them and check the answer in the back and make sure that you're doing it right. If that's a struggle for you, then do that next week. Okay? So we had already talked a little bit on Thursday about the increasing, decreasing stuff. Yeah? How can you tell if a function is increasing? Right, if it has a positive slope, it's increasing. So if the derivative is positive, then the original graph is increasing. How can you tell if a function is decreasing? Negative slope. So if the derivative is negative, then that means the original graph is decreasing. So that was our little increasing, decreasing test. And then we combine those to figure out when the derivative equals 0, if that is a maximum or if it is a minimum, because if the graph is increasing and then decreasing, then this has to be a maximum. It went up and then back down. And then if it goes from decreasing to increasing, then that means that this has to be a, then this has to be a minimum, right? Okay. So that was our little conversation on Thursday. Did we do it? Yeah, we did an actual example. We figured out a sinusoid and all that kind of fun stuff. Okay? So that's all called the first derivative test. So the first derivative tells us increasing and decreasing, and it tells us maximum and minimum. Okay? And then here are some examples of different cases for the first derivative test. We talked about this one right here. You can have a place where the slope of the tangent line is 0, but you don't have a maximum or minimum, right? So, everybody got on board? Thinking about calculus, thinking about that, thinking about the word name. Okay, so should we go back to example 1? We kind of did this, I feel like, so I'm not going to worry about that. Let's go to a new one. All right, let's find the local maximum and minimum values of this function. So what do we do first? Take the derivative. Someday that answer will change. We're getting closer. What's that? Yeah, chapter 5 is integral. So we finished this chapter. Integral. Like, art is an integral part of my life. Integral.
Does that mean it's unimportant?
No, it means like it's like weaved into the very essence of my being. What's that?
So you say your body
I've never been this funny with them. I'm always proud of them, more proud every day. Okay, so I need to take the derivative here. What's the derivative here? 1 plus 2 cosine x. So we're only going from 0 to 2 pi, so that's what it is. Now what do I do? Nope. I'm staying away from the calculator. I'm doing this with my mind. Let it equal to 0. So 1 plus 2 cosine of x equals 0. Okay. Solve for cosine. So cosine of x equals negative 1/2. Okay. Like I said, we're going to stay away from the calculator. So we have a little triangle. Now it says it's negative, right? Cosine is the x or the y? The x. So if the x is negative, then I have to be over here somewhere in the third or the fourth quadrant, correct? So let's start with the third quadrant. And cosine is 1 over what? Adjacent over hypotenuse. So if the cosine of x is negative 1/2, I guess I should make that x not theta. So this angle here is x that I'm trying to find, and this is negative 1, and this is 2. And what is this right here? Root 3. So what do we have on our angle? We'll turn the 30, 60, 90 triangle. And since root 3 is bigger than negative 1, this is this angle across from the root 3. Right, the bigger angle is across from the bigger side, so this is 60-degree angle right there. Okay, so we can just figure out that one value of x is not 60, but what? How do we always measure our angles? No, right, we're going to change the radius in a minute, but where do you always measure from? The positive x-axis. Right, yeah. So it's not 60, it's actually what? 120 degrees. Okay? Now there's another one where it's going to be negative, and that would be if this angle is 60 degrees. So again, if I start from the positive x-axis and go all the way from there, how many degrees have I passed through? 240. Okay, because that's still the 60-degree angle. And then that's all I've got because it says from 0 to 2 pi, so that's one rotation all the way around the circle. So I'm done, except for right, as you said, we want those in radians. If I multiply by pi over 180, what goes into 120 and 180 even in 60? So it would be 2 pi over 3. What goes into 240 and 180 even though 60, so it could also be 4 pi over 3, okay? What did we just find though? Yeah, basically the critical points there. So now we have to use those to figure out if they are maximum or minimum. So I'm going to put them on this little sign chart here. And then I'm going to pick a number that's not 2 pi over 3 and that is not 4 pi over 3. Okay, pi, 1, 2, whatever. What? You want to go with pi? Okay, so pi would be in between these somewhere. So if I plug pi into the derivative right here, what is the cosine of pi? Nope, that's pi over 2. Yeah, keep going down. Negative 1. Okay? Pi is 180 degrees, right? So if you go to 180 degrees, you're going to be right on the x-axis, and so that would be negative 1. So I'm going to go 1 plus 2 times negative 1, which is what? Negative 1. And so what we just figured out is that from this interval here, since the derivative is negative, what's true about the original graph? It's decreasing. Yeah, it is negative, so that means it is decreasing right here. Okay? And then it's simple, once you have one of them, what's it doing over here? Increasing. And what's it doing over here? Increasing, because it'll always alternate unless there's a multiplicity, which we'll talk about more later. Alright, so increasing, then decreasing, then increasing, so like this, and then like this. So that means 2 pi over 3 is a maximum, and 4 pi over 3 is a minimum. Okay? Now this relates to Hannah's question about how can you tell if there's going to be x or the y. The question says find the local maximum and minimum values of the function. Have we found the maximum and minimum values of the function? No. We found where they occur. But if you want to know what the values are, then you have to take them and plug them back into the function. Into the original one, yeah, because we're being asked questions about the original function, so I have to take them back into the original function, okay? So that means I have to figure out what the sine of 2 pi over 3 is. Well, for me, I have this nice little sine up here. What's the sine of this angle? Root 3 over 2, opposite over hypotenuse. So that means it's going to be 2 pi over 3 if I plug it into there. So I'm figuring out what g of 2 pi over 3 is. That's going to be 2 pi over 3 plus root 3 over 2. That's going to tell from the crazy decimal fluctuation on the calculator. We can just leave it like that. Okay, just leave it. Alright, and then I need to also figure out what the minimum is. So what would be 4 pi over 3? Let's plug 4 pi over 3 in there for x. Oh, sorry, it's 2 times that, right? So because it's 2 times x. And we figure out root 3 over 2 was the sine of that, but we put it back to that to double it. So it's actually 2 pi over 3 plus root 3, okay? So now 4 pi over 3, if I plug that in there, I get 4 pi over 3 plus, what is the sine of 4 pi over 3. Yeah, so this is gonna be negative root 3, right? We're going down, so that would be negative root 3 over 2. And I have to multiply that times 2. So those will cancel, so my minimum is 4 pi over 3 minus root 2. Okay? Again, the discussion, is the calculus difficult? No. The algebra starts to get a little bit messy, because all this time so far this year has been just kind of taking these derivatives and reading them. Now we actually have to figure stuff out. So, yeah, brush off level, good, algebra skill. Okay? All right, then the next thing is the second derivative, and we will leave that for another day. You're welcome. You can find this all in the future, but you're welcome. Okay, so let's do some problems. We don't know how to do the second derivative test. So anytime it says concavity or points of inflection, I tried to, I think it's just A and B. We don't know how to do that yet, so leave that out, okay? Okay, anybody want to say bye to,
Bye, Abby.
Bye.
Bye, Abby. Abby.